Let us start, and this is the continuation, not a continuation, the repetition of the lecture number 6 of trigonometry. Okay, so one thing I forgot to tell you in the previous lecture, there is a very small point regarding the previous concepts which what we have done so far. Very small point. You may consider this to be a question or a point or a note, whatever you feel like. I'll take this as a question. You may write this as a note or a point. Suppose, for instance, if this thing is given, sin x plus sin y plus sin z is equals to 3. This is given. Only this much is given, and what you're asked to find is you have to find the value of cos x plus cos y plus cos z is equal to what? This is the question. You have to find the value of cos x plus cos y plus cos z. Given that sin x plus sin y plus sin z is equals to 3. So what I do? What is the actual reason? How will we find out if sin x plus sin y plus sin z is given to be 3? First of all, you all know the maximum value of sin x can be 1 and the minimum value of sin x can be -1 for any sin theta. For any theta, sin theta cannot go beyond 1 or -1. So the maximum value of sin theta is 1 and minimum value of sin theta is -1. Okay. So what I do, we are going to use this concept. So over here, if you see sin x plus sin y plus sin z is equals to 3. Okay. So what can we say from here? When this is equals to 3, this is equals to 3 when sin x and sin y and sin z attain their maximum value. Which means if sin x is 1, sin y is 1 and sin z is 1, then only this will give you 1 plus 1 plus 1, that is 3. So if you give some different value to sin x, let's say 0.5 or something, then definitely you have to increase the remaining values of sin y and sin z, which is not possible. Maximum value is 1, I told you. So clearly over here, what we have is sin x plus sin y plus sin z is equals to 3, which means sin x is equals to 1. This is only possible when sin x is equals to 1, sin y is equals to 1, and sin z is equals to 1. Now you all know the value of sin x, sin y, and sin z, means x, y, and z actually. You can find out what is x, y, and z. Okay, sin x is 1, sin y is 1, and sin z is 1. So generally x, y, z will be 90 degrees in this case. Sin 90 is 1. So in this case, all three values of x, y, and z will be 90 degrees. Now you know what is x, y, and z. So you clearly put this over here and get the answer from here. What is cos x plus cos y plus cos z? So what is this? So this basically this is cos 90 plus cos 90 plus cos 90. Okay. Now cos 90 is 0. So this is 0. 0 plus 0 plus 0. So this will be 0. Now let us see some of the points. In fact, some of the angles you must remember. We have done compound angle formulas. Sin A plus B, sin A minus B, cos A plus B, cos A minus B. All these compound angle formulas what we have covered so far. Then we have also done the compound angle formulas for tan theta, tan A plus B, tan A minus B, cot A plus B, cot A minus B. Cot A plus B and cot A minus B is not widely used, I told you. But wherever it has applications, we are going to use. So it is better to know all the formulas actually. Okay. So now let us see how do we use those things actually to find out some of the angles which are unusual, but we can find out using these formulas. We can find out the value of those using these formulas, and you have to remember those angles actually. Okay, so basically we are going to use the T ratios of 30 degrees and 45 degrees to find out the value of some unusual angles. Let us see what we are trying to say from here. Suppose over here, some of the angles you must remember. Now these are some of the unusual type angles. You have the values of, let's say, 15 degrees and all, you have to remember these things. 15 degrees, then 75 degrees. Basically, we are going to use this formula only, compound angle formulas, to derive those values, actually find out those values actually. Okay. So first one, the first formula is of sine 15 degree. Sine 15 degree. Now these are unusual angle. You can see from here. Unusual type of angles. You don't know the value of sine 15 degree. You know 30 degrees. You know 45 degrees, 60 degrees, 90 degrees. But 15 degrees is an unusual angle. You know the exact value of sine 15 degrees. But 15 degree is given. This 15 degree can be expressed as a difference of two standard angles which are known to you, 45 and 30 degrees. 45 minus 30 will give you 15 degree. So 15 degree is the difference of between these two, 45 and 30. And 45 and 30 are two standard known angles to you. We write this 15 degree as sine 45 minus 30 degree. And then we use the formula of sine A minus B. Sine A minus B formula is sine A cos B minus cos A sine B. So sine 45 cos 30 minus cos 45 minus, cos 45 into sine 30. So sine 45 is 1 by root 2. Cos 30 is root 3 by 2. Minus cos 45, which is 1 by root 2. And sine 30, which is half. Now, if you calculate this value, so we have in the numerator, we have root 3 minus 1 divided by 2 root 2 in the denominator. This is the value of sine 15, you must remember. Okay. This is the value of sine 15. You must definitely remember these values. These are some unusual angles, but we have seen in various questions in JEE exam, you have seen that there has been applications of these things also. Various small questions involves the value of these angles. If you remember these, you can easily find out the answer. Otherwise, you can derive actually. Okay. In case if you forget, you can derive this particular angle. The value of this sine 15 degree is 45 minus 30. This way you can derive, but that is time consuming. It is better if you remember these values. Then we have cos 15 degree. Cos 15 degree. How will we find out cos 15 degree? Again, by the same logic, we have 15 degrees 45 minus 30. So this is 45 minus 30, cos 45 minus 30, and then simply use the formula for cos A minus B. Simple, use the formula of cos A minus B. So cos A, cos B plus sin A sin. We have done this formula in the previous lecture. We have done the formula for cos A cos B. Sorry, cos A minus cos A minus B. Actually, we have done the formula for cos A minus B. Cos 45 into cos 30 plus sin 45 into sin 30. So cos 45 is 1 by root 2. Cos 30 is how much? Root 3 by 2. Sin 45 is 1 by root 2. And sin 30, that is half. If you calculate this thing, so this is in the numerator, we have root 3 plus 1 divided by 2 root. Root 3 plus 1 divided by 2 root. So by this time, we know the value of sin 15 and cos 15. So genuinely, we can find out the value of tan 15 also, which is sin 15 divided by cos 15. Okay, so we can simply find out the value of tan 15, that is sin 15 divided by cos 15. Sin 15 is this part, root 3 minus 1 divided by 2 root 2, and cos 15 is root 3 plus 1 divided by 2 root 2. So this is root 3 minus 1 divided by 3 plus 1. Simply divide this sin 15 by cos 15. So 2 root 2 will get cancelled out, and root 3 minus 1 divided by root 3 plus 1 will be the output. So root 3 minus 1 divided by root 3 plus 1 is the result actually. So these three results you must remember. The other you can simply derive actually. Even if you remember sine 15 degree and cos 15 degree, easily you can find out tan 15 degree. There is one more way to find out tan 15 degrees. You can break this tan 15 degree as tan 45 degree minus 30 degree. Just like the same thing what we have done for the previous number 1 and number 2. What I'm trying to say is in this manner. You can break this as tan 45 minus 30. Okay. You can break this into tan 45 minus 30 degree and simply use the formula for tan A minus B, which means tan 45, tan A minus tan B, tan A minus tan B divided by 1 plus tan A tan B. 1 plus tan A tan. You can simply use this formula and put these values, you will get the same result, root 3 minus 1 divided by root 3. Okay. So either you do in this manner, or better is you remember in this manner, tan theta is sin theta by cos theta. So tan 15 is cos sin 15 divided by cos 15. Okay. So we are done with the angles of 15 degree. Now similarly, let's do the angles of 75 degrees also. Now similarly, sine 75 degree, cos 75 degree. Let's find out the value of sine 75 degree and cos 75 degree. Okay, we have seen for 15 degrees. Now let's see for 75 degrees. In fact, 75 and 15 degrees are basically complementary of each other. Two are complementary angles. If you can see from here that let's say for the fourth one, continuing the formulas, sine 75 degree. Sine 75 degree, you can solve in both the ways. Let's solve it the first way. In the first way, 75 degree is given. In fact, 75 degree is actually the sum of two standard angles. We don't know the value of 75 degrees, but we can write this in the sum of two angles, which are known angles. 45 plus 30. 45 degree, 30 degrees, all of you know the value of 45 degree and 30 degrees. So 75 degrees, 45 plus 30 degree. Okay, so this is actually sine 45 plus 30 degree. In the place of 75, simply write this as 45 plus 30 and use the formula of sine A plus B, that is sine A cos B plus cos A sine B. So this is sine 45, 1 by root 2. Then we have cos 30, root 3 by 2. Cos 45, 1 by root 2. And sine 30, which is half. So this is root 3 plus 1 divided by 2. Either you solve in this manner or there is one more way. What is that way? Very simple. Sine 75, if you observe, sine 75, 75 degrees actually 90 minus 15 degree. 75 degrees actually 90 minus 15 degree. Two of them are complementary. 75 and 15 degree are complementary of each other. So sine 90 minus 15 will give you 75 degree. Sine 75 degree. Okay. So what is sine 90 minus theta? Theta is 15. Sine 90 minus theta is cos theta. So this is cos 15 degree. And what is cos 15 degree? We have seen previously. Cos 15 degrees, root 3 plus 1 divided by 2 root. Root 3 plus 1 divided by 2. So sine 75 and cos 15 degree will have the same value. The reason is very simple. Reason is both of them are complementary of each other. Okay. Both of them are complementary of each other. Come down to the next one. Next angle. I hope this is clear. Both the ways are clear. So next is cos 75 degree. Cos 75 degree. Again, same thing. Cos 75 degree, we can write this as 45 plus 30 degree. So this is cos 45 plus 30 degree. 75 is not a known angle. Obviously, we will write this in the, we can write this in the difference or sum. Sum basically, we can write this in the sum of two standard angles which are known to us, 45 and 30 degrees. So this is, now use the formula for cos A plus B. So this is cos A, cos B minus sin A sin, minus sin A sin. So cos 45 is 1 by root 2. Cos 30 root 3 by 2. Okay. Minus 1 by root 2. Sin 45 is 1 by root 2 and sin 30, that is half. So here we have root 3 minus 1 divided by 2. Okay. Root 3 minus 1 divided by 2. So you can clearly see from here cos 75 is again root 3 minus 1 divided by 2 root 2. Again, you can use the previous logic. Similarly, 75 we can write this as cos 90 minus 15 degree. 75 can be written as cos 90 minus theta, cos 90 minus 15 degree. Cos 90 minus theta is sin theta. So in this case, theta is 15 degree. So this is the same as sin 15 degree. And we know the value of sin 15 degree. What is this? Sin 15 degree is actually root 3 minus 1 by 2 root 2. So this is root 3 minus 1 by 2. So cos 75 degree and sin 15 degree are the same. Once again, the same reason. 75 degree and 15 degrees are complementary of each other. Even if you remember 15 degree, that's all. You can easily find out what is sin 75 degree. Just remember sin 15 degree, cos 15 degree. In fact, you should remember these things. This should actually strike to you immediately because, you know, in the exam, you don't have so much of time to derive every concept and then write it. So definitely you have to memorize the two values, and this 75 degrees should immediately strike to you. In case if you know the 15 degree value, 75 degrees must initially strike to once you see what is 75 degrees, if the question involves 75 degrees. Okay, next one. Similarly, we have the sixth one is of tan 75 degree. Now you know sin and cos, so genuinely you can find out the value of tan 75 degree, that is sin 75 degree divided by cos 75 degree. So this is root 3 plus 1 divided by root 3 minus 1. This by this divided by this. Okay. Root 3 plus 1 divided by 2 root 2 divided by root 3 minus 1 upon 2 root 2. So you will get the values, that's all. Okay, clear? Now let's move to the next question. The next concept actually, not question. Next concept. You may write this down as a note. These are some of the observations, important observations you must genuinely know actually. You may write this down as a note. Whenever you see the format of 1 minus tan theta divided by 1 plus tan theta, whenever you see this format, 1 plus tan theta upon 1 minus tan theta upon 1 plus tan theta is given. Immediately you will write this as tan pi by 4 minus theta. Immediately you will write this as tan pi by 4 or 45 degree minus theta. Simple reason. What is the reason? Tan pi by 4 minus theta, if you break this, how to prove this? Very easy to prove. If you break tan pi by 4 minus theta in the formula of tan A minus B, that is tan A minus tan B divided by 1 plus tan A tan B. A is pi by 4, B is theta in this case. Tan pi by 4 is what? 1. This is tan theta upon 1 plus tan pi by 4 is 1. 1 into tan theta. But that's all. We are getting this thing. But you should remember this thing. The moment this relation, if you see this relation, you have to immediately write this as tan pi by 4 minus theta. Okay. Similarly, just like the same, we have 1 plus tan theta upon 1 minus tan theta. Once you see this thing, directly you will write this as tan pi by 4 plus theta. Tan pi by 4 plus theta. Tan pi by 4 plus theta, why? Again, the same reason, simple reason. If you expand this thing, tan pi by 4 plus theta is tan pi by 4 plus tan theta divided by 1 minus tan theta, tan A tan B, tan pi by 4 into tan theta. First, that's all. Tan pi by 4 is 1 and this is tan theta divided by 1 minus tan theta. Hence proved. So this relation, these two relations are important observations. You must definitely remember. Okay. Mostly you will get this on the left hand side. You will get this 1 minus tan theta upon 1 plus tan theta. You will get this in some questions. You will get this relation and you have to directly after seeing this thing, don't do so much calculations. Tan pi by 4. 1 is tan pi by 4. Directly write this as tan pi by 4 minus theta. Bus. Okay. Next. Third one. If suppose you get this relation cos theta plus sin theta divided by cos theta minus sin theta divided by cos theta minus sin theta. Okay. Cos theta plus sin theta divided by cos theta minus sin. Then immediately once you see this expression, immediately this will strike that this is actually tan pi by 4 plus theta. Again, tan pi by 4 plus theta. Now, what is the reason behind this? Again, simple proof. Cos theta plus sin theta divided by cos theta minus sin theta. On the left hand side, if you divide by cos theta, on the left hand side, if you divide by cos theta in the numerator and the denominator, what you will get? 1 plus tan theta divided by 1 minus tan theta. Just now we have seen 1 plus tan theta divided by 1 minus tan theta is actually tan pi by 4 plus theta. What we are doing, we are dividing by cos theta in the numerator and the denominator individually. So cos theta by cos theta, which is 1, plus sin theta upon cos theta, which is tan theta, divided by 1 minus cos theta by cos theta. So 1 minus sin theta by cos theta. So 1 plus tan theta divided by 1 minus tan theta. And just now we have seen in point number 2, this is nothing but tan pi by 4 plus theta. Okay. Now, similarly, we have cos theta minus sin theta divided by cos theta plus. So this is tan pi by 4 minus theta. Again, you divide by cos theta in the numerator and denominator. What you will get? 1 minus tan theta upon 1 plus tan theta. By number 1, we will have tan pi by 4 minus theta. Very simple idea. How to remember this? 1 minus tan theta upon 1 plus tan theta. If you have a minus sign over here in the numerator, so we have a minus sign over here in the formula of tan pi by 4 minus theta. You all know in the formula for tan A minus B, in the numerator we have tan A minus tan B divided by 1 plus tan A tan B. In the numerator you have a minus sign, so in the formula also we have tan A minus B. So for minus over here we have minus over here. For plus over here we have plus over here. Similarly for plus over here we have plus over here. And for minus over here, and we have minus over here. So whenever you see these forms, actually directly you will write this as tan pi by 4 plus theta or tan pi by 4 minus theta, as the case may. Okay, this will save you time. Otherwise you have to genuinely solve this. Once you see 1 minus tan theta upon 1 plus tan theta, what you will do, you will replace 1 by tan pi by 4, then tan pi by 4 minus tan theta upon 1 plus tan pi by 4 into tan theta, because tan pi by 4 will have the value as 1. So tan pi by 4 into tan theta will be there. So genuinely we won't do so much of calculations. Means this thing, what I'm saying is this thing, this calculation. Okay. Why shall we do so much of things? Just directly we will see this thing and simply apply. Simply we know the formula, we know the format, 1 minus tan theta upon 1 plus tan theta. Once you see this format, directly replace the value of tan pi by 4 minus theta. Similarly, you will see the value of cos theta plus sin theta upon cos theta minus sin theta. Directly replace the value this by tan pi by 4 plus theta. Okay. So these values, these things must be very clear to you. Fine. Very simple concepts. Now come down to the next one. Let's see some of the use of this thing. For instance, suppose these formulas. Let's see one example based on this formula. Let's see. Suppose you are asked to prove that cos 10 degree plus sin 10 degree upon cos 10 degree minus sin 10 degree. This is equals to tan 55 degree. You have to prove this thing. Cos 10 degree plus sin 10 degree upon cos 10 degree minus sin 10 degree is equals to tan 55 degree. If you carefully observe on the left hand side, we have cos theta plus sin theta upon cos theta minus sin theta. Theta is same 10. So what is the process actually? If you know the format, then you will directly replace the value. Cos theta plus sin theta upon cos theta minus sin theta. So which is tan 45 plus theta. This is what tan 45 plus theta. So tan 45 by the previous formula, this thing. We have plus over here cos theta plus sin theta upon cos theta minus sin theta. So this is tan 45, tan pi by 4 plus theta. So this is tan 45 degree plus 10 degree. That is tan 55 degree. Now this is in shortcut way I'm saying. Otherwise, formally, how will you solve? Just by observation, we have solved this thing. We know the relation. So from there, we are solving this thing. How will you solve this formally? Formally, you will solve in this manner. Cos 10 degree plus sin 10 degree is there. What you will do? You will first divide both sides. Means divide in the numerator and denominator by cos 10 degree. So this will become 1 plus sin 10 upon cos 10, which is tan 10 degree upon 1 minus tan 10 degree. What we are doing? We are simply dividing numerator, divide numerator and denominator by cos 10 degree. Okay, divide numerator and denominator by cos 10 degree. So we'll get this format 1 plus tan theta upon 1 minus tan theta. Now we can genuinely do this. We can write this 1 as tan pi by 4. Tan 45 is 1 plus tan 10 degree. upon 1 minus, we know the formula, we have to bring in the format of the formula of tan A plus B. Here we have plus, so we try to bring this in the format of tan A plus B. So 1 minus tan 10 degree. What is tan 10 degree? Tan 10 degree, we can write this as tan pi by 4 into tan 10 degree. Because tan pi by 4 is 1. Why will we write this? Now this turns out to the formula of tan A plus B. Tan A plus B is what? Tan A plus tan B upon 1 minus tan A into tan B. So this is tan A plus B. Tan A plus B is A is pi by 4. Sorry, A is pi by 4. Let me rub out. A is pi by 4 and theta is 10 degree. Basically 45 degree plus 10 degree, which is tan 55 degree. This is the formal way of proving. Otherwise, if you know the format cos theta plus sin theta upon cos theta minus sin theta, directly you have to express this in terms of tan. So directly you will write this as tan 55 degree. Why? Because we know the format already. Tan cos theta plus sin theta upon cos theta minus sin theta is tan 45 plus theta. Tan pi by 4 plus theta, which is tan 55 degree. Okay. Clear with this? Acha, one more thing. One more thing. Till now, you have known the formula of tan A plus B. In fact, we can generalize the formula. We can generalize the formula for, like, we can find out tan A plus B. We can find out tan A plus B plus C. We can find out the formula for tan A plus B plus C plus D and so on. In fact, we can generalize this into tan A1 plus A2 plus A3 and so on up to AN. N number of terms can be there. So we have a general version of the tan A plus B formula, basically. General version. Okay. Now, genuinely, we don't need it actually, but if suppose that is required in some question, we can use the formula tan A plus B plus C. I'll show you. Tan A plus B plus C. The formula for tan A plus B plus C is actually tan A. You may write down the formula first. Tan A plus tan B plus tan C minus tan A tan B tan C divided by 1 minus tan A tan B plus tan B tan C plus tan C tan A. Okay. This is the formula for tan A plus B plus C. Proof is very simple. What you can do initially to prove this, take A plus B as A, take this as A and take this as B. And then simply break this in the formula of A plus B, tan A plus B. Means treat this as A and treat this as B, suppose. Or treat this as alpha and treat this as beta. Now find the formula for, you know the formula for tan alpha plus beta. After breaking this into tan alpha plus beta, again replace the value of alpha and beta. Again break the alpha into tan A plus B and simply simplify that expression. Okay. Means what I'm trying to say is in this manner. I hope you're getting what I'm trying to say. Break this as treat A plus B as A. Okay, tan A plus tan B divided by 1 minus tan A tan B. Okay, I have treated A plus B as A and C as B actually. So A plus B, tan A plus B plus tan C upon 1 minus tan A plus B into tan C. Okay. Again break this tan A plus B using the formula of tan A plus B, tan A plus tan B upon 1 minus tan B, tan A tan B. So once you do this, so you're done. Okay, once you do this, so you're done. And to memorize this thing, what you can do, you can use some shortcuts to memorize this thing. You can use some shortcuts to memorize this formula. Okay. What shortcuts we shall use? The shortcut to memorize this, you can, in the place of this thing, tan A plus tan B plus tan C, what you can do, you can write here as S1. What is S1? Taking sum at a time, one at a time. S1 means sum. One means taking sum one at a time. Here we have three elements, A, B, and C. Tan A, tan B, tan C. Three elements are there. So we are taking sum one at a time. Tan A plus tan B plus tan C. S1 minus product is what? Product. Here we have product tan A into tan B into tan C. So S1 minus P. S1 minus P divided by 1 minus P stands for product actually. 1 minus what we have over here, tan A tan B plus tan B tan C plus tan C tan A. So you can see this cyclic order this is going actually, tan A tan B plus tan B tan C plus tan C tan A. So this is 1 minus sum taken 2 at a time. Sum taken 2 at a time. If you have done quadratic equation, then you can know what are these expressions. So this is sum taken 2 at a time. So this is 1 minus S2. So S1 minus P upon 1 minus S2. S2 stands for sum taken 2 at a time. See, we are taking 2 at a time. Tan A tan B plus tan B tan C plus tan C tan A. So sum taken 2 at a time. So S1 minus P upon 1 minus S2. So this way also you can remember the formula. In general also we have a formula, but I'll say that later on. Okay. Right now we need this much compound angle formula actually. Okay. Now let us solve some questions. Okay, we start with some very simple questions. You have to find out the value of cos 70 degree plus cos 10 degree plus sin 70 degree to sin 10 degree. This is our first question. Now clearly we can see that cos 70 degree plus cos 10 degree and sin 70 and sin 10 degree. Over here we have A and B. This is also A and B. So here we have cos A cos B plus sin A sin B. So clearly this is of the formula of cos A minus B, which is cos 70 minus 10 degree. We know the formula of cos A minus B, which is cos A cos B minus plus sin A sin. So cos 70 minus 10 degree, which is nothing but cos 60 degree. And what is the value of cos 60? R. Let's solve one more question. Okay, we have the next question. We have to find the value of this expression. Simplify and find out the value of this expression. Sin 40 degree plus theta into cos 10 degree plus theta minus cos 40 degree plus theta and sin 10 degree plus theta. How do we solve this one? Again, simple thing, simple concept. If you observe, this is actually sin A cos B minus cos A sin B. Observation, simple observation. So here we have sin 40 plus theta, which is, this is A. If you treat this as A and treat this as B, so sin A cos B minus cos A sin B, which is nothing but the formula of sin A minus B. The sin A minus B means sin, in this case, A is actually 40 plus theta and B is what? B is actually 10 plus theta. That's all. If you simplify this thing, so theta will get cancelled out. So we are left out with sin 40 minus 10 degree, which is nothing but sin 30 degrees, and sin 30 is. Okay. I hope this is clear. Okay, now we have this question. We have to find the values of sin x plus y and cos x minus y and tan x plus y. Some informations are given. Sin x is 3 upon 5, cos y is minus 12 by 13, and xy belongs to the second quadrant. X and y belongs to the second. Now here we have sin x is positive, but cos y is negative. Okay. So to find out sin x plus y, what we do? We use the formula of sin a plus. That is sin x into cos y plus cos x into sin y. Okay. We know the value of sin x, which is 3 upon 5. We know the value of cos y also, which is minus 12 upon 30. But we don't know the value of cos x. So we need to find out cos x. So to find out cos x, we can get cos x from this relation. Cos square x is 1 minus sin square x. Okay, from the fundamental identity, we know sin square x plus cos square x is 1. So cos square x is 1 minus sin square x. Now simply replace the value. Cos square x is 1 minus sin x is what? 3 upon 5. So sin x is 3 upon 5. Sin square x will be 3 upon 5 whole square, which is 9 upon 25, which is 16 upon 25. So cos square x is 16 upon 25. So cos x is what? Plus minus 4 upon. Now whether this is positive or negative 4 upon 5. Whether cos x will be positive or negative. Obviously, we can decide that by this given information. Xy belongs to second quadrant. If x belongs to second quadrant cos x is negative. So generally cos x will be minus 4 upon 5. Because x belongs to second quadrant. X belongs to the second quadrant. So here we have 3 upon 5 times minus 12 upon 13 plus the value of cos x now is actually minus 4 upon 5. And sin y, do we know what is sin y? We don't know what is sin y. So let us find out what is sin y. Again, similarly, we use this relation. Sin square y is 1 minus cos square y. Okay. So sin square y will be 1 minus cos square y. That is minus 12 upon 13 whole square. That is 144 upon 169. So 169 minus 144, that is actually 25 upon 169. The sin square y is this. Obviously, sin y will be what? Sin y will be plus minus 5 upon 30. Now, similarly, whether this will be plus 5 upon 13 or minus 5 upon 30, we look onto this information. Xy belongs to second quadrant. So obviously, in this case, this cannot be negative. Why? Because sin theta is positive in the second quadrant. So this is sin y will be positive 5 upon 30. Now we know all the values. Now simply put this over here. So this is actually minus 4 upon 5. Sin y is now actually 5 upon 13. Now simply calculate this thing. That's all. So we are done. So this is how much? So this is minus 36. Minus 36 upon 13 times 5. That is 65. And this is minus 20 upon 65. So minus 36 minus 20. That is actually minus 56 upon 65. So the answer to this question is actually minus 56 upon 65. Okay. So here, one important point for this question is this information xy belongs to second quadrant, or which quadrant, the location of the quadrant, sin theta, cos theta. You must obviously always verify. Do not blindly put all values plus theta or minus theta. Always verify what is Where does xy belongs actually? In which quadrants does xy lies? Okay, always verify this thing. Now you all can try out for cos x minus y and tan x plus y. Okay, cos x minus y you can find out using the formula of cos a minus b. Use the formula of cos a minus b, that is cos a cos b, cos x cos y minus plus sin x sin y. And similarly, the third one, tan x plus y, if you know what is cos x plus y, you can find out cos x plus y also. So you can easily find out sin x plus y upon cos x plus y. Okay, so the remaining two I am leaving for you. Similar to the first one. Use the formula, that's all, we are done. Okay, let's move to the next question. Okay, now we have this question. If sin a minus b is 1 upon root 10, cos a plus b is 2 upon square root 29, you have to find the value of tan 2a. The condition given here is a and b lies between 0 and pi by 4. How will we find this? First of all, tan 2a, regarding this tan 2a, what I do, I write this in such a way, if you can see over here, what is given, a minus b and a plus b. So I write this tan 2a in terms of a plus b and a minus b. How will I write this? Means 2a basically. 2a, I'll write this in terms of a plus b and a minus b. Clearly, you can see from here, because we have to use these informations, right? So what we can do is we can write this 2a in terms of a plus b and a minus b. So this is tan a plus b plus a minus b. So here you can see the adjustment what I have done. B and b cancels out. You are left out with 2a. So a plus b is also used. A minus b is also used. Now treat this as a, treat this as b, and use the formula of tan a plus b. So that is tan a plus b plus tan a minus b upon 1 minus tan a plus b into tan a minus b. Okay. Now individually from these information, sin a minus b and cos a plus b, we are going to find out what is tan a plus b and tan a minus b, and simply put this over here in this expression. That's all. So we are done. Let's find out those values actually. So a plus b and a minus b. First of all, over here we have this condition given. Be very careful. This is given. AB lies between 0 and pi by 4. So where does we need to figure out a plus b and a minus b lies? Okay, always figure out this thing. Otherwise, you will have problem while understanding the angles, whether the angles are positive or negative. Okay. So first of all, a lies between 0 and pi by 4. B also lies between 0 and pi by 4. So clearly you can see a plus b, the minimum value of a plus b will be 0 only. And the maximum value of a plus b will be pi by 2 from here. Pi by 4 plus pi by 4, that is pi by 2 actually. You can clearly see from here, minimum value, this is the minimum value and this is the maximum value. So minimum to minimum, a plus b will take the value of 0, and maximum this can take pi by 2. Now what about a minus b? What is the minimum value of a minus b and maximum value of a minus b? A minus b, minimum to minimum can take the value how much, and maximum to maximum can take the value how much. So regarding a minus b, do not do this thing 0 minus 0 and pi by 4 minus pi by 4. Understand the concept. A minus b will be minimum when A is minimum and B is maximum. A minus B will be minimum when A is minimum and B is maximum. B attains the maximum value. So maximum value of B is what? Pi by 4. So then only A minus B will be minimum. That is basically minimum value will be minus pi by 4. Because minimum value of A is 0. So 0 minus pi by 4 will give you minus pi by 4. Clear with this concept? A minus B will be minimum when A is minimum and B is maximum. A is minimum when A is 0. B is maximum when B is pi by 4. So 0 minus pi by 4 will give you minus pi by 4. Similarly, A minus B will be maximum when A is maximum. Ulta now, when A is maximum and B is minimum. A minus B will be maximum when A is maximum, B is minimum. So A is maximum means A is pi by 4 and B is 0, which is pi by 4. Maximum value is pi by 4. Okay. Now, is this range still correct? Is this range still correct? We have found out this range to be A minus B lying between minus pi by 4 and pi by 4. This is still not correct. The reason is here sine A minus B is 1 upon root 10. Right? Sine A minus B is 1 upon root 10. Means sine theta A minus B is positive. Sine theta is positive. So if sine theta is positive, A minus B cannot lie between minus pi by 4 and pi by 4. Obvious reasons. A minus B cannot lie in between minus pi by 4 and pi by 4. Sine theta, sine A minus B is positive. So gradually we have to correct this. After correction, our new range of A minus B is from 0 to pi by 4. Then it is satisfied. Then it is satisfied. After correction, our new range is 0 to pi by 4. We observe this thing and then we proceed. So A minus B, the range of A minus B is actually 0 to pi by 4. So these are our new ranges. A plus B lies between 0 to pi by 2 and A minus B lies between 0 to pi by 4. Now we might find out simply the values of tan A plus B and tan A minus B. Okay. Clear? So next we can simply use the triangle method. We simply use the triangle method from here, A minus B basically, to find out the values of cos A minus B and tan, sine A plus B. Okay. Let's say for A minus B, first of all, we have sine A minus B is 1 upon root 10. Sine theta is actually perpendicular upon hypotenuse. So over here we have root 10. Okay. The hypotenuse is actually root 10 and perpendicular is 1. So clearly base will be how much? Base will be 3. Right? Base will be 3. So we can clearly find out what is tan A minus B. Tan A minus B will be how much? 1 upon 3. Perpendicular by base actually. Now whether this will be positive, this is satisfied over here. See, A minus B lies between 0 to pi by 4. This is satisfied. This is positive. This positive value will be satisfied. So whether this will be positive or negative, this must be satisfied using this relation. You must verify. So that's why we are actually finding out this thing. You must verify this thing, that whether tan A minus B is positive, negative, what should be the output according to this values actually. A minus B lies between, in which quadrant does A minus B lies? Accordingly, we find out the value of A minus B and we decide whether that is positive or negative. Okay. So similarly, we can find out the value of sine A plus B. Right. In fact, we can directly find out the value of tan A plus B. A plus B lies between 0 to pi by 2. And what is given? Cos A plus B is 2 upon root 29. So cos theta means, cos A plus B means Base by hypotenuse. So base is what? Base is actually 2 and hypotenuse is √29. Okay. So perpendicular is how much? 5. Perpendicular is 5. So tan A plus B is actually perpendicular by base. That is actually 5/2. Clear? So now we have all these values. What we can do, we can simply take this and put this over here in this expression. Tan A plus B is 5/2. Tan A minus B is 1/3 upon 1 minus tan A plus B, which is 5/2, and tan A minus B, which is 1/3. Now simply calculate this thing. This is how much? Tell me, what are you getting? This is how much? This is 15. 15 plus 2, 17. 17/6. And this is 1/6. So this is clearly, this is 17. 17 must be the answer. You all are getting 17? You all are getting 17? Great. Okay, now let us move on to the next type of questions. Okay, here we have this question now, which says we have to prove this actually. Tan 70 is tan 20 plus 2 times tan 50. Basically, we have to see that whether this relation holds or not. Okay. We have tan. All the entire expression is involving tan over here. In terms of tan, it's given. So over here, what should we do in order to prove this expression is true? Actually, that tan 70 is tan 20 plus 2 times tan 50. Here, one thing, one observation, what you have to make. First observation, we are having tan. Everything, all the expressions are in terms of tan. So then generally, we can think of using some formula for tan in terms of tan. And obviously over here, if you carefully see, the angles do have some relations in between them. 70, 20 and 50. Right? The angles, the bigger angle, whatever is the bigger angle. This is the bigger angle. 70 degrees is having some relation with 20 degree and 50 degree. Obviously 70 degrees 20 plus 50 degrees. So we will start with this relation now. That is tan 70 degree. We will start with this relation tan 70 degrees tan 20 plus tan 50. Basically, we are writing 70 degrees as 20 plus 50 degrees. Okay. Tan 20 plus 50 degrees. Next, what do we do? Definitely, yes, we are going to use the formula for tan A plus B. So tan A plus tan B upon 1 minus tan A tan B. 1 minus tan A tan B. What is our main target? We have to prove this relation. This relation tan 70 is the same as tan 20 plus 2 times tan 50. We are starting off with tan 70. What is the idea? Basically, we are observing 70 has some relation with the remaining angles over here. 70 is the largest angle. Definitely, there is some relation. 70, the largest angle, will have some relation in between the two smaller angles. Basically, 20 and 50, they are having some relation. 70 is 20 plus 50. So tan 70, we are starting in this manner. Tan 70. You can see that the right hand side expressions in terms of tan 20 and tan 50 is given. But after we are breaking into this formula, we are getting this as tan 20 plus tan 50 upon 1 minus tan 20 to tan 50. What do we do next? Let us cross multiply and see, because we have to bring this expression. Let us cross multiply and let's verify. So if you cross multiply this thing, cross multiply this. So here we have tan 70 minus tan 20, tan 50 and tan 70. Okay. And right hand side, we have tan 20 plus tan 50. Tan 20 plus tan 50. Next, what do we do? To bring this expression tan 70 is tan 20 plus 2 times tan 50. Here, one thing you can observe, the sum relations between the angles so that we can get some cancellations. Can you observe 20 degree and 70 degrees are complementary of each other? 70 is complementary is 20 actually, isn't it? We can write this 70 as what? Tan 90 minus 20. Complementary of 70 is what? 20 degree. So tan 90 minus pi by 2 minus theta, that is cot theta. Isn't it? So this is simply straight away cot 20. So this cot 20, which is nothing but 1 by tan 20. So this cot 20 and this tan 20 will get cancelled out. We will be only left with tan 50. So ultimately what we are getting, if you take this term tan 50 on the right hand side, here also we have tan 50, so we are done. You can clearly see the relation getting formed. Tan 70 on the left hand side is left out, so you take this remaining term tan 50 on the right hand side, so here we have tan 20 plus 2 times tan 50. That's all, we are done. Okay. Simple question. So what is the idea? Whichever is the bigger angle, just try to observe whether the other two or the remaining angles are getting some relation or not. Basically, the bigger angle, you try to break the bigger angle. You try to break the bigger angle in terms of the two smaller angles or the remaining smaller angles, not only two or just the smaller angles you have present in the expression actually. Let's do some more questions of this type. Okay, so now we have this question. We have to prove that this relation holds tan 3x into tan 2x into tan x equals tan 3x minus tan 2x minus tan x. Again, the same logic, what you can observe from here. What is the logic over here? Express the bigger angle in terms of the sum of the other two smaller angles. Okay. Express the bigger angle in terms of the sum of the other two angles. Right. So here clearly you can see the bigger angle is what? The bigger angle is 3x. 3x being the bigger angle and 2x and x being the other two smaller angles. So what you do is you express 3x. What we can see from here, clearly we can see that 3x is actually 2x plus x. Some relation is there. All terms are in terms of tan. So definitely there is some relation. What we can use is the formula of tan a plus b. Clearly what I'm trying to say, you can see from here that 3x is actually 2x plus x. Okay. In fact, we write tan 3x as tan 2x plus x is the same as taking tan on both sides. Tan 3x is actually tan 2x plus x. Start from this relation. Now keep on simplifying the right hand side. Over here, you'll get the relation and then simply cross multiply. Over here, this cross multiplication thing is very, very important. So tan 3x is tan 2x plus x. What you do, you break this. So this is tan 2x plus tan x divided by 1 minus tan 2x into tan x. Tan 3x. Now what you do, you just simply cross multiply over here. So this is tan 3x minus tan x into tan 2x into tan 3x is equal to tan 2x plus tan x. Okay. So aren't we getting this relation? Is this what we need to prove? We just simply take this term on the right hand side and we are done. That's all. Simply take everything, this right hand side on the left hand side. So like tan 2x plus tan x on the left hand side. So this will become tan 3x minus tan 2x minus tan x. And on the right hand side, we are left out with, take this on the right hand side. So we have tan x, tan 2x into tan 3x. And this is what we need to prove. Tan 3x, tan 2x, tan x is equals to tan 3x minus tan 2x minus tan x. Okay, pretty simple. So what is, again, the same type of observation? We are starting with the relation of the angles. We are seeing that 3x can be broken into 2x plus x, and then we are taking tan on both sides, and we are simply simplifying, and then after all, cross multiplication. So this is one types of questions actually. Similarly, you try out one question for your homework. Okay, you try out this question for your homework. Cot x into cot 2x minus cot 2x into cot 3x minus cot 3x into cot x is equals to 1. We have to prove this thing. Okay. Again, the same logic you can clearly see from here. There is some relation between the bigger angles and the remaining two smaller angles. 3x is what? 2x plus x. In the same manner, what you will do over here is after the relation, basically this relation 3x is equals to 2x plus x, you have to use the formula for cot a plus b, because all the expressions are in terms of cot. If you use tan, then this will be lengthy, I'm telling you. Okay, so in this case, I have told you cot a plus b or cot a minus b formula is not widely used, but whenever it is used in some questions, like there are some questions where you have to use the formula of cot a plus b, like over here. Okay, so you have to use the formula for cot a plus b. I hope you remember the formula for cot a plus b. Cot a plus b is what? Cot a cot b minus 1. Cot a cot b minus 1 divided by cot a plus cot b. Cot a plus cot. Okay, so you have to use this relation. Use this relation in order to prove this. Okay, so this is your homework. You will try out this for your homework. Okay, let's see some important points now. You may write this down as a note. These are important points which you have to remember. Important points and observation. You write this down as a note somewhere, and these are the points which you need to remember. Actually, there have been questions previously, so obviously these are important points. Okay, here we have the first point. It says if a plus b is equals to pi by 2, then tan a times tan b is equals to 1. What is the meaning of this thing? If a plus b is equals to pi by 2, this condition is given, then we have tan a times tan b is equals to 1. This is the first point. How do we prove this thing? Proof is very simple. There are various ways to prove actually. So one of the ways, let's say, let me show you one way, the very simplest way I'm showing you. If you have a plus b is equals to pi by 2, what you can do from here, from this relation is you can write a as pi by 2 minus b. Okay. If a is pi by 2 minus b, and if I take tan on both sides, so tan a is actually tan pi by 2 minus b. Okay. What we get from here? Tan a is actually cot b, because tan 90 minus theta is what? Cot theta. So this is cot b. So cot b is the same as 1 upon tan b, isn't it? Or basically you simply write this as tan a as cot b. Replace tan a by cot b. So cot b times tan b is what? 1 only, because cot b and tan b simply cancel out. Cot b is 1 upon tan b. Okay. So this is how we prove this relation. So you must remember this thing. So if a plus b is equals to pi by 2, then tan a into tan b is actually 1. Important relation. Let's see one question where I can apply this concept actually. Suppose, for instance, if you are asked to find out the value of this product. if you are asked to find out the value of this product, tan 1 degree into tan 2 degree into tan 3 degree and so on up to tan 88 into tan 89, you are asked to find out the value of this particular product. How will you find this? Again, angle observation is the main key over here. So what I do, if you observe the angles, 1 degree and 89 degree are complementary of each other. 1 degree and 89 degree are complementary of each other. Basically 1 plus 89 is 90 degree. Similarly 2 degrees, 88 degrees are complementary of each other. And similarly you will see 3 degree, 87 degree are complementary of each other. Isn't it? Basically 1 plus 89 is 90. 2 plus 88 is 90. 3 plus 87, sorry. 3 plus 87 is 90. So these two angles, the pairwise, they are complementary of each other. Basically, if I club them, like tan 1 degree and tan 89 degree, tan 2 degree into tan 80 degree, I'm simply clubbing them up, okay? And so likewise continues, like tan 3 degree into tan 87 degree, and so on. Okay, so what is the idea? What is the value? We actually use this theorem. If a plus b is equals to pi by 2, then tan a into tan b is 1. So if a plus b is pi by 2. If a plus b is pi by 2, then tan a into tan b is 1. So then this value is 1. This value is also 1. Tan a into tan b. Because 2 plus 88 is actually pi by 2, 90 degrees. So tan a into tan b is 1. Tan 2 degree into tan 88 is 1. This thing is also 1, and so on. The remaining values will be also 1. Okay. Likewise, you keep on pairing, the remaining values will be also 1. Only one tan something, tan theta will be remaining. What is that actually? If you try to observe from here, this product is what actually? This product is starting like in this way, tan 1 degree, 2 degree, 3 degree, and so on. It continues actually. Okay. So if you pair them up in this manner, so you will get 1, 1, 1 continuously, all the products will become 1. Only one thing will be remaining. What is that? Basically this manner, in this manner, basically 1 into 1 into 1 and so on. Similarly 1 into 1 into 1. Likewise over here, in between there is only one thing which will be remaining, which can't be paired with, that is actually 45 degree. Tan 45 degree will be remaining in between, and the value of tan 45 degree is also 1. So this is actually the product will become 1. So the result of this product is actually 1. This is a famous question. You will find this particular question in almost every book actually. Okay. So here you can use this particular logic. What we have previously learned is this thing. You can learn, easily now use this thing. I hope the how to use this particular concept in this question is now clear to you. Okay. Let's see some more questions or more points. Actually, we were actually learning the points. Let's continue with the points. Okay, this was the first one. Let's move to the second one. Second one, you can consider this to be a question. In fact, you can write this as a question also, or you can just simply write this as a point only. Better to write this as a point. Let's see the second one. Okay, we have this thing as if a plus b plus c is equals to pi, then we have to prove that tan a, tan b, tan c is equals to tan a plus tan b plus tan c. This is one relation. Although we are going to study these type of relations further in conditional identities also, but let's see this point over here. We are using the formula of a plus b, tan a plus b basically. So it's more or less based on the same thing what we are doing so far. So over here, this condition is given that a plus b plus c is equals to pi, then we have to prove that this thing. Let's prove this. Let's prove this. A plus b plus c is equals to pi. So what I do, I write this a plus b as pi minus c. Okay, from this relation, basically, I write this a plus b as pi minus c. and then I take tan on both sides. Here you can see that the angles over here, what they're asked to prove is in terms of tan. A, B, C are given so over here, and one condition is given. So what I do, I write this A plus B as pi minus C and then take tan on both sides and then simplify. So tan A plus B is tan pi minus C. Now expand this thing, tan A plus B, by the formula of tan A plus B. So this is tan A plus tan B. Logic is the same. Simplification after taking tan on both sides and then cross multiply. 1 minus tan A tan B. The right hand side we have tan pi minus C. Tan 180 minus theta is how much? Obviously minus tan theta. I hope you remember this thing, right? 180. This is 0 and this is pi. Pi minus theta. Pi minus theta means over here, second quadrant, sign is positive. Tan is negative. So clearly this is minus tan C. Okay. So next what? You simply cross multiply and simplify, you will get the result. So simply cross multiply and you will get the result. So here I have cross multiplied. Now next what? Simply take this thing on the left hand side. So we are done. That's all. That's what we are asked to prove. Okay. So this is the way how we solve these type of questions. Some conditions are given. Now you have to remember this thing. This is a very important identity. You have to remember this thing. Okay. Further, we're going to see this under conditional identities also, but this is a very important identity which you need to remember, that if A plus B plus C is equals to pi, then tan A tan B tan C is equals to tan A plus tan B plus tan C. Okay. One more way is there. You can prove this actually is using this way. Sorry. One more way you can prove is actually using the formula of tan A plus B plus C. I hope you remember tan A plus B plus C formula. Where is it? I gave you this formula. Tan A plus B plus C. If you use the formula of tan A plus B plus C, then it may happen that the number of steps is reduced. If you have this formula, you better use this particular thing. S1 minus P upon 1 minus S2. That's the way I told you to remember this actually. Okay, so better what you can do is over here itself. If you use in this relation only, in this relation, what I do, I use tan A plus B plus C. Formula of tan A plus B plus C. So right hand side is tan pi, which is 0. If you take tan on both sides, so right hand side will be tan 0. Tan pi basically, that's 0. Left hand side you have S1 minus P upon 1 minus S2. S1 means sum taken one at a time, means tan A plus tan B plus tan C, minus P. P stands for product, tan A into tan B into tan C. Right? Divided by 1 minus S2, sum taken 2 at a time, which means tan A tan B plus tan B tan C plus tan C tan A. This is equals to 0. Again, the same thing. After doing this simplification, you just simply cross multiply, you will get the result. Here, maybe you can reduce 1 or 2 steps over here. Okay, likewise over here, you are using 4 steps. You may reduce some of the steps while solving in this method. Okay. In general, the formula in general actually for A plus A1 plus A2 plus A3 and so on up to AN, I'll show you later on. That's the formula in general, but do remember this formula. S1 in this manner, you remember S1 minus P upon 1 minus S2. Okay, just a way to remember actually. Okay, clear for all? Also, you must also remember this particular identity. Important identity you have to remember. Important relation you have to remember. Now let's solve one question. Okay, we have this question next. We have to show that this relation is true, given that this condition is given. So we have A plus B is equals to 45 degrees, and we have to show that 1 plus tan A times 1 plus tan B is equals to 2. Again, the logic is the same. Some condition is given, A plus B is equals to 45 degrees. So what I will do is I will take tan on both sides. So here we have A plus B, tan A plus B is equals to tan 45 degrees. Okay. Next, what will I do? I will simply break this into the formula of tan A plus B. So here we have tan A plus tan B upon 1 minus tan A tan B. Right hand side we have tan 45, which is 1. So now what we do? Simply cross multiply, that's all. So we have tan A plus tan B is equals to 1 minus tan A into tan B. Okay. What we have to prove? 1 plus tan A into 1 plus tan B is equals to 2. Okay. So we have to bring these into factors. 1 plus tan A into 1 plus tan B. We have to factorize basically. Not so difficult. We can simply factorize. So tan A plus tan B is equals to 1 minus tan A tan B. Take all the tan terms on the left hand side, because right hand side you can see is a constant and left hand side we have in terms of tan. So better is you take all the terms of tan on the left hand side. So tan B plus tan A tan B is equals to 1. Okay. Now what I do, right hand side you have to bring 2 actually, right? So here one thing I can clearly see, here I have tan B. I can take tan B from this factor. If I take tan B from this particular part, from this part actually, if I take out tan B as common, so I'll get 1 plus tan A. Okay. To bring this factor 1 plus tan A, what I will do, I will add 1 on both sides. Now, why we are doing this actually? Just to bring this 1 plus tan A as the factor. From here, if you take out tan B, you will get 1 plus tan A as the factor. So similarly, to bring out 1 plus tan A, I can clearly see if I add 1 on both sides, this is becoming 1 plus tan A. And from here we are taking out tan B common. So here we are getting 1 plus tan A. Right hand side also we are getting 2. So you can see the factors are getting common out. So here we are getting 1 plus tan A. Okay. 1 plus tan A into 1 plus tan B, which is equals to 2. That's what we are asked to prove. Okay. Easy question, not so difficult. A very common type of question you will find out again in almost every. Now let's solve one question from ISI 2012. Okay, so here we have the next question from ISI 2012. XYZ is given to be the angles of a triangle. We have to prove that tan x by 2 into tan y by 2 plus tan x by 2 into tan z by 2 plus tan z by 2 into tan y by 2 is equals to 1. First of all, again, the same type, similar type of questions what we are doing so far. Over here we have on the place of the condition, they have mentioned x, y, z be the angles of a triangle. That's your condition actually, upon which what we have to work out. X, Y, Z be the angles of a triangle. We have to prove this thing. Now, clearly, when X, Y, Z is the angles of a triangle, then one thing should definitely strike, that is X plus Y plus Z is equals to pi. The angles, the sum of the angles is equals to 180 degrees is equals to pi. So we are going to simply use this thing. X plus Y plus Z is equals to pi. Now, if you carefully see the angles, angles are all in terms of X by 2, Y by 2, means in terms of sub multiples. X by 2 and Z by 2, Z by 2 and Y by 2, all in terms of sub multiple. So X plus Y plus Z is equals to pi, which means if I want to bring this in terms of sub multiples, that means in terms of X by 2, Y by 2 and Z by 2, what will I do? I will simply divide by 2 on both sides. So this, I will get this as X by 2 plus Y by 2 plus Z by 2 is equals to pi by 2. Okay. Next, what will I do? I will try to use the formula of tan A plus B. Now, what I can do, the simplification over here, I can do is x by 2 plus y by 2. I take this z by 2 on the right hand side. So here we have pi by 2 minus z by 2. Then we take tan on both sides. Because you can see from here that the angles are involving x by 2, y by 2, z by 2. I take tan on both sides. So here I have tan x by 2 plus y by 2 is equals to tan pi by 2 minus z by 2. Now tan 90 minus theta is cot theta. So this is cot z by 2. Fine. Now left hand side, I express this in the formula of tan a plus b. So this is actually tan a, tan x by 2 plus tan y by 2 upon 1 minus tan x by 2 into tan y by 2. And right hand side, we have cot z by 2. Now here we don't have any cot terms in the expression what we need to prove actually. So better is I change this into tan z by 2, 1 upon tan z by 2 and then cross multiply, because ultimately we need to cross multiply, you know. Definitely yes, we need to cross multiply in order to get our required proof actually. Okay. So now I cross multiply. So just simply cross multiply and we are done. You can see from here. So if I cross multiply, I get tan x by 2 into tan z by 2 plus tan y by 2 into tan z by 2. And right hand side, I'm getting 1 minus tan x by 2 into tan y by 2. So then what? You simply take this term on the left hand side. So we are done. That's what we need to prove actually, right? So tan x by 2 into tan y by 2. You take this term on the left hand side. So we have tan x by 2 into tan y by 2 plus tan x by 2 into tan z by 2 plus tan y by 2 into tan z by 2 is equals to 1. So we are done with the proof. So sometimes such type of easy questions are also given by the ISI. This was asked in ISI 2012, so way back in 2012 although. So you can sometimes you can expect such type of questions, easy questions also in your ISI. Yes, this was a subjective question.